so here we go. Here we go. So, first, this is the world. Yes, good. There's always one person who knows what I'm talking about. That's great. Homework. Homework. What do you want to talk about from the homework? What do you want to start with? We 25 because I didn't give you the diagram, so we're skipping that. How about 6 and 7?
Yes.
6 and 7, okay?
Yeah.
Yes, please? Okay, so on 6 and 7, they give you a base function, and you need to modify the base function. You need to start with this. There's your base function, and turn it into 6. There are 2 transformations that happen to turn it into 6. What's one of them? Someone raise their hand and tell me what's one of them. Fowler.
It stretches vertically by a factor of 2, so you put the 2 before the radical sign.
Yes. So it's going to be 2 f of x, 2 times the function.
Yep.
What's the second thing, Nell?
It shifts horizontally to the right by 2, so you add in -2.
Exactly. Exactly. Good. So what does it come out to be? Y equals the square root of, well, 2 on the outside, 3 times x minus 2 minus x minus 2 squared. Exactly. Ooh.
Wait, it has to be squared?
Oh wait, x has to be squared.
Oh, it's in that original.
You have to subtract 2 from all the x's. You can't just pick which one you're subtracting it from. All the x's. All the x's are equal. Everybody's equal in math, unlike Americans in the United States.
What?
We have some of the biggest differences in terms of wages, poverty, health insurance. I was actually being serious.
You said that.
Unlike.
Okay, cool.
All the x's are equal, unlike Americans.
Got it. Now I get it.
Like 30 million kids under poverty line in the United States? It's pretty sad. Something huge, yeah. 30 million. There's an amount of money calculated. There's a numeric value, like how much money what the income that supports them.
What the number is.
I don't know what the number is. I don't know.
It's about 18,500 in Vermont.
Yes, in Vermont it varies by state. Yeah, $500. Yeah, in Vermont. No, you can survive, but there's a poverty line. And so in terms of, this is how one way you compare different countries, things like literacy, education level, what percentage of your population lives under the poverty line, that kind of thing. The United States is number 1 in a lot of things that are really, really, really staggeringly weird and way far behind in many other things. Like our infant mortality rate, we're ranked 27th in the Western world. We have the 27th worst infant mortality rate in the world. Yeah.
Who's on solid please and decide what's important?
That's not a percentage, right? Not like
Recording. Okay, 7 here. 7. Let's do number 7 here. So we have our base function. Is that stretched or compressed in any way?
No.
So that there is rigid transformations. It's not stretched. No, it's not. No. No, it's not. It's not stretched at all.
So that means we won't have
It's 3 things. And this is what I want you to do. I want you to flip it first. I want you to do flipping first. So what's the first step going to be? Negative f of x. What's the second going to be? Down 1. Let's go down 1. And then we'll shift it. So plus 4. Right? Now how can we test this? Let's test it the fun. We kept on doing it, kept on coming out to a straight line. We had no idea why. And it turned out we kept on using the x values. No, don't do that. You're modifying the y values. The x values are your inputs. Don't touch them. Modify your y values. So did this get flipped over? Yeah. It's just not in the 3rd or 4th quadrant because it was moved up 3, and that was enough to move it out of the 3rd and 4th quadrant.
Lower deck, would you see?
Sure. What would c do to this? Let's just make the new values. We know that the I'll fit it in over here. So this would be c right here. So what are you doing? You're just doubling all the y values, right? So it's 0, 8, 2, and so this stays the same, right? And this goes to 8, so like up here. And then this one's 1, that goes to here. And that goes to 4. So what does this thing look like? There it is. You stretched it vertically. Got it?
Actually, I'm going to go to 2.
Oh, 2. Sorry, I didn't go down far enough, did I? It goes down to here, right? Correct?
Alright, you think.
Take it easy, especially since these are just lines, right? So if you're moving around lines, all you need to do is do the endpoints of the segments. How do you get any of these things to curve? Well, the modifications that we're making with A, B, C, and D, like the coefficient in front, can any of those A, B, C, or D values, can any of those make a line into a curve? No, we can stretch them, and if you stretch a line, what is it still going to be? Still a line. You have to use weird functions, well, much more interesting functions than the one we're using to do this. Okay, anything else from the homework before we move on? Okay, good. And so combination of functions, simply put, really straightforward, everybody. You are adding and subtracting, dividing, and multiplying two functions together. And we're going to use some big kid notation to describe these occurrences. So if f and g are functions and they have two domains, the domain of f is going to be A, the domain of g is going to be B. If you combine f and g together into one function, what is their new domain? The domain is the set of all input values, so you need values that can get put into both functions. So if this is the domain of f and this is the domain of g, what is the domain of when you add them together? The intersection of the sets. So if you can plug in from 0 to 5 into one function, and you can plug in from 1 to 6 into another function, what's the domain when you add them together? 1 to 5. That stays the same for subtraction and multiplication. What's the only thing that changes when you're dealing with division? You can't divide by. Can a function, is it okay if just a function equals 0? Absolutely. A function can definitely just equal 0. But if that function suddenly becomes the denominator of a fraction, you can't do this. You have to avoid it.
What about negative square root?
Well, yeah, that's get taken care of specifically by the domains that you already have. You're already going to take care of that, but the only thing that can get added in with this new operation called division is dividing by 0. That's the only thing that could get added in. So if I gave you a few of these as practice, how about you try these right here? Example 6. So I would like you to, well, before I do this here, let me just pause this. So,
That looks like so much fun.
what do you have to do first if you're going to figure out the domain of any of these combinations? What do you have to do first?
You have to find the domain of f of x.
Yeah. So if f of x, what's the domain of f of x?
All numbers except the negative.
Yeah, so say the positive, greater than or equal to 0. So all besides negative, yes. And what's the domain of g?
Everything except for negative
Or 2. No.
Mmm.
No. It's from negative infinity to 2.
Can it be 2?
Yep.
No.
No.
Yeah, it can be 2.
Yeah, it can.
A function can be 0, that's fine.
Oh, I get
So it's between those two. So now that you have that, can you answer all these questions? What's the intersection of these two? What's the intersection?
From 0 to 2.
Yeah, from 0 all the way to 2. So the domain of f plus g, the domain of f minus g, and the domain of fg is that right there. What's now the trick though is if you wanted f over g is f of x over g of x, right? And that's going to be the square root of x over the square root of 4 minus x squared. So that's going to be what?
Same except you don't count 2.
Yes. So it's strictly less than 2. The only thing that changes is that, because it can't be 2, because it can't be 0. The denominator can't be 0. Absolutely. Very good. The blue is the function g right here. You're adding to the function f, which is right there, and it turns into this function up there. Structurally, what's the difference between the yellow and the red right there? Are they kind of similar?
Yeah, but that one like
It looks like it's a little stretched, right? Can someone explain to me why it looks a little stretched?
Because it's added a linear function. So.
Yes, you're not adding a constant amount. If you add a constant amount, you would just take the graph and what would it do? Just move up the same amount everywhere. But look, you're adding more and more and more and more and more, so it's going up further each time. So what does that do to the shape of the graph? It stretches it. It's going to stretch it. From here to here, the height right there, that's f of a. The height right there is, g of a, right? What's the height right here? F of a plus g of a. And then for the bonus question, what's this distance right there? Yes, because you're adding f of a to g of a. Good. Nice. There you go. You got it. Okay, so what about this one? This is graphically, it does look like ice cream. Kind of a happy rainbow ice cream.
No.
I don't like ice cream. I'm not human. We have two functions here. These are the two functions we just looked at, Hannah. Here is 4 minus x squared, and here is the square root of x. If you add two functions together, what do you end up with? You end up with this arc right here. That arc ends at those points. Does that match what we had before? Yes. What was the domain here? The domain of g of x was? Yes. And what's the domain of this one? X greater than or equal to 0. So the domain better be the intersection of the two. So where does it go to? It goes all the way to 2, and it stops at 0. So does that match visually what we figured out numerically? Yeah, absolutely. The only thing I really want to say about finding the domain of a function, just be really careful. Don't take it for granted. Some of the hardest domain functions look really simple, and they're not. They're really not. Sure. Have you ever found the intersection of lines? What's the most common way you have found the intersection point of two lines? Set them equal to each other, but what there's different methods you learned. What's the name of that method? Yeah, say it. Substitution. In substitution, what are you doing? You are taking...
one and putting in another.
Yeah, you're taking one what?
Variable in one way and putting in another.
You're taking a function and you're plugging it into another function. You are substituting. This is exactly what we're doing here. We're taking a function and plugging it into another. So we have two functions, f and g. The main thing you need to get used to is the notation. Do you see the open circle? Does that mean multiplication? No. It makes me sad when on the next test some of you are going to be cruising through and you're going to start multiplying functions. Makes me very sad. It is composition. 3 different ways to write it. FOG is the same thing as FOG of x, which is the exact same thing as f composed of g of x. Which function is being keyed off first? Which function are you doing first?
G of x.
G. Then you take the output and you plug it into f. There's two functions going on here. Just like doing one and then the other. That's it. So visually, what does this look like? Well, you take x, you plug it into function machine g, and you get out g of x. You then take that and you plug it into f, and what do you get out? F of g of x. Yeah. Can you tack on as many functions as you want?
Yes.
Sure. Can you compose an arbitrary number of functions together? Sure. Generally speaking, how many do we see? 2 or 3. 2 or 3. Here's another way to see it. You have a certain domain, you take x, you act g upon it, and you get g of x, and then you take g of x and you act f upon it, and you get f of g of x. That's the same thing as doing f of g and ending straight there at f of g of x. It's the same exact thing.
What's the domain of
Finding the domain is another story. It gets more complicated when you're composing. Finding the domain of composite functions is going to take a little bit more work, meaning actually some work, than finding the domain of combining functions, which is generally like a 2-step process. You find the domain of one, you find the domain of other, and then you find out where they intersect, and then you're done. You might have to do a little logicking to cut out the zeros. This takes a little bit more work. Was there a question in the back? No? Okay, so the questions I would like you to try. The only hint I want to give you, don't make it harder than it is. Do not make it harder than it is. Any of them. Yes. Oh, what about this one? FOG, what does that mean? F of g of x. What is f of x? So that's going to be g of x squared. So what's that? Done.
Wait a second.
Nope. G of x. What's that mean? G of... Is someone tired over there? Yeah, it happens. So what is that? F of x minus 3. So what's that equal to? Done. That's it.
Oh,
Yeah. Okay, so V's, I'm not going to do all 4. Which one do you want to do? Number 4? Which one's number 4? We're doing D. We'll do A first. How about that? Let's do A. A first. So FOG is going to be, you can do the whole, you can write it out like this if you wanted to, which is the same thing as f of g of x. So that's going to be the square root of
Square root of
g of x. So what's that going to be? The square root of
square root of
2 minus x. Yes. So here's the, yeah, absolutely.
Well, and that is the fourth.
What's the domain?
Yes. So what's the first of all, is there any division?
No.
No. You only have to worry about the root. So you need to make sure 2 minus x is what? Or equal to 0, right? So 2 is greater than or equal to 0, equal to what? X. So x is less than or equal to 2. Does x second square root change anything? No, because we've already guaranteed it's going to be positive. So what's the domain of this function? Done.
But you can simplify the
Oh, you could say 2 minus x to the 1/4 if you wanted to. Okay, so let's do C or D. Which one? D? Let's do D. So that's g of g, right? So that's going to be what?
Can we start with the
Actually, let's do g of f. I like g of f better, actually. Sorry. I like this one better. G of f. So that's going to be g of f of x. So you're plugging f into g. So it's going to be the square root of 2 minus f of x. 2 minus what?
The square root of x.
Like that? Is that it? Sure. So we have to be really careful here. We now know that 2 minus the square root of x has to be what?
But greater than 0.
Or equal to 0. Right? Does everybody see why that's true?
That's C, right? This is C.
This is not, this is, sorry, this is
Oh, this
B.
is B.
I'm sorry. Do you agree with that? 2 minus root x has to be greater than or equal to 0. Is that true?
Yeah.
So 2 has to be greater than or equal to root x. So the square root of x has to be less than or equal to. So what does x have to be?
4
Or what?
or 0.
Wait, can you plug in negative? No.
From 0 to 4.
0 to 4. So that's true about the whole thing. But also, you know that the square root of x is in there, right? You have to be careful of pieces inside. So what does that mean? It means x has to be greater than or equal to 0. Both of these things have to be true. Where do they intersect? Well, they intersect right there. Both of those things have to be true.
So it's the same principle.
Essentially, you just have to pick the right pieces. Yes.
So these functions intersect not on one point but along this.
Mm-hmm. That's correct. So that would be the domain of that function. So let's keep on going here. You want to do D, right? Yeah, let's do D. So it's g of g. So that's going to be the square root of 2 minus g of x, right? So that's going to be the square root of 2 minus the square root of 2 minus x. So you know that 2 minus the square root of 2 minus x has to be greater than or equal to 0. So you know that 2 has to be greater than or equal to the square root of 2 minus x. Let's just flip the order. Has to be less than or equal to 2. What do you do to both sides?
You put square on it.
Sure. It's going to be less than or equal to.
4.
So keep on going on this one. Your homework will get pasted into your notes. Get out of here.